and welcome to what is probably one of the most famous and most commonly used and most important methods of integration, namely integration by parts. You're probably not familiar with and you're not aware of how important this method is, but it will become apparent as you take more calculus courses, as well as more courses which are based on calculus, including physics and all kinds of engineering applications. As you can tell from the formula that you have in front of you, this method has something to do with the product rule, right? And in fact, it's the same rationale as with the method of change of variable. Namely, that the product rule is in fact behind the method of integration by parts, and this is how it works. Let's develop the method. So as we did for the method of change of variable, we're going to start with the product rule, which says that the derivative of a product is given by the derivative of the first times the second plus the derivative of the second times the first. Alright, well, to every differentiation formula corresponds an integration formula. And here is what the integration formula looks like in this case. The antiderivative on the left hand side is of course f times g, and the antiderivative on the right hand side is going to be the sum of the two antiderivatives of those two products, whatever they are. Great. So what that means is that if I want the integral of something that looks like f prime g dx, all I had to do is write fg and subtract the integral of g prime f. You say, what does that do for us? Well, basically this method does not really give you an answer to the original question of integrating the left hand side of the equation you have in front of you, but it gives you a way out of a possible problem. Here is actually how the method works. Remember, the one on the formula on the right hand side is in fact the formula we're going to be using, the formula that we've found works. So how we're going to be using it? So if the integrand looks like it's of that form, so it's the product of a derivative times a function, then what we're going to do is, first of all, we're going to rewrite it if it is needed or useful. That's always the first step. Then we're going to compute the derivative of the g of x piece. Okay, so the g of x should be a function that is easy to differentiate. Okay, then we're going to compute one antiderivative of f prime of x. Of course, we're thinking of it as in the form of f prime because we want to compute its antiderivative. So we're going to have to assume that the antiderivative of f prime of x is, so the original f of x, is in fact easy to compute. If we can do that, and if we can compute the integral of the new product, the product of f times g prime, so the derivative of g and the antiderivative of f prime, then we can use our formula and figure out what the original integral was all about. So this looks a little bit like a method where we're running around in circles, but again, as long as this second new integral is easier to compute, and it will be in the applications we are going to use, then this formula turns out to be very, very useful and very effective.